Hey everyone, today we're going to try to explain the reactions of chapter 16, Carbonyl Reactions, and they all follow the same simple logic. So we're going to try to explain that logic, and if you understand it, and I hope you will, then all of these reactions would seem easy and you would just remember them all by that simple logic. So what you need to look at is the basicity of the leaving group. And good leaving group would be a weak base. So the weakest base would be chloride or bromide, like all the halogens. And then after that, like this is the best leaving group because it's the weakest base. And then you would have the leaving group of the acid anhydride, which is this leaving group. And then you have the OH and the OR. They're not very weak bases, but they come in the middle and their basicity is similar. And then the strongest base is the amine. Like in organic chemistry, they're relatively strong bases. So if you look at these acyl chlorides, they're the most reactive because they have the best leaving group, the weakest base. And then what comes after that? Which would be the most reactive after acyl chlorides? So you look at the leaving groups. So you look at the leaving group what's marked in yellow. So here, this one, as we said, this comes number 2. So these are the second most reactive compounds, the acid anhydrides. And then you have your carboxylic acids and esters. They're similar. And then the least reactive would be the amides because they have strong base as their leaving group. All right. So how do you memorize all of these reactions? So you always replace your leaving group in this chapter with either OR. You see OR, it's always OR, or OH, or amine. Like you want to create an ester or a carboxylic acid or an amide. And if you want to create an ester, you react your compound with alcohol. And if you want to create a carboxylic acid, you react it with water. And if you want to create an amide, you react it with amine. Okay, so it's always the same. As you look at every section in this table, you can see it's either reacts with an alcohol, water, or amine to create amides. Same thing, except like for example, if you see here, there is no water. Why? Because it already has, it's a carboxylic acid, so you can't replace OH with an OH, it's the same thing. So you just, what remains is an alcohol and an amine. Here, same thing, you have water, alcohol, and you can't react it with an amine because it's already an amide, so you just have water and alcohol. Okay, same thing, alcohol, water, and amine. So what you really actually need to remember is the simple things. For example, because we said this is very reactive, so it has only one arrow forward because it's reactive. So it's gonna go all the way to the products here as well. So this is like the most simple reactions are acyl chlorides and acid anhydrides because they follow the same pattern. They're very reactive, they go one way towards the products, and there is alcohol, water, and amines. It's the same thing, alcohol, water, and amine. So it's the same thing. In the first reaction, you replace your good leaving group, chlorides, with OR, and then you replace it with OH when it reacts with water. and then you replace it with an amine to create an amide when you react with an amine. Okay? So these are the first two. They follow the same pattern. Okay. Now, when you get to esters, they have another thing that you need to remember. Well, firstly, if you look at the first reaction, you can see, as we said, the OR, and so here you replace an OR with a different OR, and as we said, like the OR and another OR have the same basicity, so it's not gonna go all the way the products. You're gonna have an equilibrium because you're not replacing a good leaving group with a strong base. You're basically replacing a relatively strong base with a similar strength of a base, so it's not gonna go all the way to the products. Okay, now what you need to remember in this section here is that when you have a base catalyzed esterification, or when you have a base catalyzed hydrolysis, it's gonna go all the way because you're basically adding a strong nucleophile, strong base. You're not adding only water, you're adding OH minus, which is a stronger base than the leaving group. Water is a weak base. Okay? And it follows the same pattern. You have first trans esterification, which you replace an OR group with a different OR group. If it's acid catalyzed, it's an equilibrium. If it's base catalyzed, then it goes all the way to the products. Same here. If you have an acid catalyzed hydrolysis, it's an equilibrium, and you replace OR with an OH, which have the same basicity. And if it's base catalyzed, it goes all the way to the products. So here you react with an alcohol, here you react with water, and here it doesn't need a catalyst because, as we said, the amines are stronger bases. They're stronger bases, they're worse leaving group, but they're better nucleophile. So this is a better leaving group than this. That's why it goes all the way to the products to form amides. Okay, so this is the third section. Fourth section has only two reactions. You can either replace an OH group with an OR group, and because they have the same basicity, so it's an equilibrium. So here you replace the OH group with an OCH3, an OR group. And the second one you form, okay, this is a bit tricky because this is a base and this is a carboxylic acid. As you know, the acid reacts with the base, it gives it a hydrogen. That's why here, you don't expect to form an amide immediately because the acid would want to give the base hydrogen. So this is a salt that forms, so it forms a salt. That's why this reaction is a bit problematic. But if you heat it, if you run that reaction in a very high temperature, you get your amide in the last step. Only with heat. Still, this reaction is problematic. If you have this carboxylic acid and you want to make an amide, you can do this, but there is a better reaction that you can transform and convert this carboxylic acid to acyl chloride to make it more reactive. And how you do that, we will talk about it, but here are the two reactions. Okay, so if you react a carboxylic acid or a carboxylate with SOCl2 with heat, you replace the OH group with chloride, so you get a more reactive compound that you can just react with an amide and you get your amide. Or if you react with PCl3, you also get an acyl chloride, which is more reactive. Okay, so we talked about 4, save this 5. What's left is the amides, and as we said, they're not reactive because this is a strong base, it doesn't want to leave. So as you notice, there's always heat and there's always a catalyst. Okay, so it can react with water under acid or base catalyst. The difference is that if you have a base catalyst, in the end, like first you would get an OH group, but because you have a base, so the base takes this hydrogen from the carboxylic acid. So at the end, under a base catalyzed reaction, you get this compound, which is the conjugate base of the carboxylic acid. So you can convert this NH2 of the amide to either OH group or O- under, if you react with water under basic conditions, or you can just create an ester if you react the amide with an alcohol. So the OR group replaces the NH2, and under normal condition it won't, because the OR group is a better relieving group than the NH2, but because you have a catalyst and you have heat, so it happens. So remember, when you have amides, there's always heat and there's always a catalyst. Just remember, when you react an amide with water, it can go either under base catalyst or an acid catalyst. And these are all of the reactions. So if you follow this simple logic, it can be complicated the first time. If you just practice a little bit, it can be easier to follow the logic and not just memorize all of them. So I wish you good luck, and if you have any questions, you can add me on Skype. It's in the description, and I'd gladly help you, of course, for free. Good luck.